Wasabi, you guys. Welcome to Integration B Training for Intermediates. And in this section, we'll be doing hyperbolic substitution. I think this would be our last hyperbolic technique. I think so. But hyperbolic substitution, it's literally the same concept as trig substitution, but with hyperbolics. So that's all it is. ln square x plus square root of x squared plus 1. So we definitely don't want to, integration by parts. And I don't know how you can U-sub this as well. So, and if we try to Trig-Sub, like let x equal tangent theta, then we'll end up getting ln square of tan theta plus secant theta times secant square theta, and I don't know if you want to deal with that. What do you even do with that? More integration by parts? Like that's a no-no. So instead, to replace that, we use hyperbolic substitution. So hyperbolic trig-sub, pretty much. So we'll let x equal sinh theta. Now why? Why am I letting x equal sinh theta? Because it's the same purpose as trig-sub. Our whole goal is to get rid of that. Our whole goal is to get rid of that square root. Now, what I like about hyperbolic trig-sub is not only it gets rid of the square root, it gets rid of the ln. And you'll see why. Watch this. So sinh theta, again, sinh square plus 1 is equal to cosh square. So when we do x equals sinh theta, dx is equal to cosh theta, d theta. And so now what this is going to give us is ln square, and then sinh theta. I'll go ahead and abbreviate this. So we have sinh theta plus sinh theta plus 1, sorry, sinh square plus 1, which is cosh square, square rooted. This gives us cosh. Okay? So now we have s plus cosh, and then cosh theta d theta. Okay, but how does this make it easier? Well, if you remember, I don't know why, I just decided, there we go. But sinh theta plus cosh theta, if you remember, this is e to the power of theta. And so now this will give us theta square of cosh theta d theta. And now this is just integration by parts. So we do theta 2 theta to 0 CS, just like that. And now we have our answer. So now this is, what is theta? Theta is equal to inverse sinh of x. So we have sinh theta, which is x. So this is h. I don't know why I said h. This is x of sinh inverse squared. And then we have minus 2. I'm not even going to bother simplifying it, so I'm just going to put 2 cosh inverse sinh. And then inverse sinh. And then plus 2x. Because sinh theta is x. And I guess this is our answer. So again, if we try doing trig-sub, let x equal tangent theta, then we will end up with tan theta plus secant theta being cubed with secant square at the top, and it's just, it wouldn't be good. It would be ugly. It would be very ugly. So when trig-sub doesn't work, hyperbolic trig. So let x equal sinh theta, and this will give us cosh theta d theta, and then of course we already know what this turns out. This gives us e 3 theta. Okay, so now we have negative 3 theta here. Again, exponentials, we could just go e theta plus e negative theta d theta. Working with exponentials, not that bad. So I'm gonna put a half here, and then we get e to the what? Negative 2 theta plus e to the negative 4 theta d theta. And now this is a half of e negative 2 theta over minus 2, and then also minus negative 4 theta over 4. Okay, and now we simply put it back in terms of x, so this will be over 4 e to the negative 2 inverse sinh, right? And then this is also minus with a fraction of 8 e to the negative 4 sinh, inverse sinh. And we just leave our answers like this. Okay, a lot of radicals. A lot of radicals. A lot of radicals. What do we do here? We have a lot of radicals. Let's see, if we do trig substitution, again, we just end up with secant theta plus tangent theta. And it's just no. No. So, if we do hyperbolic Trig-Sub, well, let's just see what happens. In this case, we're gonna let x equal cosh theta. Okay, again, the reason is because cosh theta minus 1 is equal to sinh square, and that's gonna get rid of that square root. So we'll end up having cosh theta sinh theta d theta, and then square root of e to the theta. Okay. And this gives, if you remember the trig identity, times 2 divided by 2. This is a half of sinh 2 theta with square root of e theta d theta. What are we going to do with the square root of e theta? What are we going to do? We're going to do everything in exponents. Right. We're just going to exponentially integrate this. So we have a half. We have e to the theta over 2. It won't be pretty. I'll let you know that. This won't be. It won't be a pretty algebra, but I mean, you know, you're just gonna have to bear with it. Okay. Let me just put 1/4, and then if I distribute, we get a 2 plus a half. That's 5 halves. And then minus e negative 2 plus a half. That's negative 3 halves. Yes, I'm actually thinking about this because I'm not good with fraction arithmetic. Okay. So it's just this. And then we just go ahead and integrate. We just straight up integrate this. 1/4. And then this would be 2/5 of e 5 halves. Theta is inverse cosh. And then minus, well, this would be plus 2/3 of e negative 3/2 of inverse cosh plus c. Alright, cool. So hyperbolic trig-sub, it's very weird to get used to, but again, it's very useful. How are we going to solve this integral? So there's two ways. The one way that I would do it is probably advanced, but it's there's an identity, and that's inverse sinh. This is equal to the ln of x plus square root of x squared plus 1. Now, the reason why this is easier to memorize is just because of, let x equal sinh theta, right? Then this is theta, let sinh theta go here. This is also equal to theta. That's how I know they're both equal. That's just how I memorize it. And you could do the same process with inverse cosh. But let's say you don't know that identity. Then that's okay. You can let u equal inverse sinh. And then you'll end up with sinh u. Or actually, technically, I guess a better way to see it is you're it's like a loophole trig-sub. So you're doing x equals sinh theta, right? So you're making this theta equal like that. So this whole thing's going to be e to the theta, but then you have cosh theta d theta, right? This is one of the integral that we did in our previous video, right? So you could just do it exponentially, and then you're good to go. I think this is like a half of e to the 2 theta plus 1, right? And then yeah, you just go from there. I'm lazy, so I'm gonna do this. We know that this is ln all that, so it was x plus square root of actually, you know what, I lied. You know what, I like your way. I like the exponential way. The exponential way is a lot easier. Let's do exponential. You know what, screw it. E to 2 theta over 2 plus theta, and then this would be theta would be inverse sinh over 2 plus inverse sinh. There you go, that's my answer. Okay. This looks wild. This is a very wild integral. I don't know how we're gonna what should we do? If you let x equal tangent theta, we'll end up with tangent theta plus secant theta plus 1, and that's no. So because of that ugliness, we're gonna do x equal sinh theta. So we're going hyperbolic. Okay. Then this is cosh theta d theta. This whole thing here would be e theta plus 1. Okay. So it looks like we're gonna have to go hyperbolic. Hyperbolic it is. Have that half there. And we have this. But then what do we do with this? What are we gonna do with this? Well, I like to take out that negative exponent. So e to the 2 theta plus 1, e theta plus 1. I'm going to leave it like this. Okay. And now I have a choice. I have a good choice, actually. I'm going to do plus e theta minus e theta. Now, what this is going to do is, well, this first term here, this gives me e theta over e theta plus 1. This here, I just get e negative theta. And then this here, I'll have minus e theta plus 1, plus e theta, then plus e theta, which is 2 here. Okay, and then this whole thing would be negative theta. Okay, alright, got it. So now the whole answer is going to be ln of e theta plus 1, and then minus a half of e to the negative theta, and then minus, this is theta. I'm sorry, they're not theta. I don't know why I put theta. When you cancel this out, this would be 1. So it'll be negative theta over 2. Okay, and now we plug in inverse sinh. So what we have is e to the inverse sinh, x plus 1, minus a half of e to the negative inverse sinh, minus a half of inverse sinh. Man, our answers have been very long. Our answers has been very long, but I mean that's because these integrals they're not very easy. They're not easy at all. These are integration bee problems. They're always going to be tricky. All right. So this is full of radicals. I see that x plus square root of x squared plus 1. You know exactly what I'm going to do. We're going to do hyperbolic Trig-Sub. Let x equal sinh theta. And this will immediately give us the square root. Oh wow, would you look at that. If we plug in sinh theta here, we get cos theta. And then our d theta has cos theta as well. So our cos theta is going to cancel out. So we'll be left out with this. I'm just skipping ahead because for the sake of time. But yeah, we have e to the power of theta over 2. Cool. That's nice. Wow. This is just 2 e theta over 2. Okay. So then our answer is just 2 times e to the half of inverse sinh. Plus c. Huh. Is there a time where we should just use Trig-Sub? I don't know. Let's see. If we let x equal tangent theta, we get tan square secant square on top. 1 plus secant theta. I mean, you can conjugate secant theta minus 1, but then you'll be left off with secant cubed minus secant theta. I'm doing all this in my head. I don't know, but that looks like a nightmare. What happens if we do hyperbolic sub? In this case, sinh theta, we get sinh square with cos theta, and then we have 1 plus cos. Okay. 1 plus sinh square is equal to cos square. Note that sinh square is equal to cos square minus 1. And this is factorable. Aha, that's what we have. That's what we have. So we can. So this simplifies to the integral of cosh minus 1. Wait a minute, but then we have cosh square. But I mean, that's okay. That's okay. We know how to deal with that, right? We know how to deal with that. Cosh square, no problem. Exponentially do it, right? That's 1/4 e to the 2 theta plus e to the negative 2 theta plus 2, right? And then minus cosh theta. Okay. Then our answer is just simply 1/4 e to the 2 theta over 2 minus e to the negative 2 theta over 2 plus 2 theta, and then minus sinh theta. And so our answer is just, let's see, 2 inverse sinh over 8 minus e to the negative. I guess you can put this in sinh form, right? This whole part here, this is technically sinh 2 theta. That's what that is. So this is 1/4 of I guess we could put it in this form, inverse sinh, and then plus 1/2 of inverse sinh, and then minus x, pretty much, right? Okay, that is our answer. So this looks wild. This looks very crazy as hell. But if we let x equal sinh theta, right, then we end up with, well, the bounds 0, 1. That's like I don't know what that is, but I'll leave it like that. 1 plus root 2. Okay. So is that right? I think that's right. I don't know. Inverse sinh of 1 is that, whatever. But then we have inverse tanh, and then sinh cosh here, this is tanh theta, and then don't forget our d theta, right? So now we have this is just theta cosh theta, pretty much. Integration by parts, right? And then we are left off with theta sinh theta. I guess I could just leave it as inverse sinh of 1, but then here this is cosh theta, 0 to inverse sinh of 1. This is just 1, so we get ln. We get ln 1 plus root 2 minus I don't know what this equals, so I'm just gonna leave it. And then we also have minus, let's see, 0, cosh 0 plus 1. And I think this is our answer. Another one of these. Let x equal sinh theta, right? And then this would just simply be theta. And then we have cosh theta, then another cosh theta from our d theta. So cosh square theta d theta. Yeah, I don't know if I want to integrate by parts. Huh. Well, do you think it's better to do it exponentially as well? I don't know. If we do that, we get e theta, 2 theta, sorry, plus e to the negative 2 theta plus 2. Right? Oh, wait a minute. Wait a minute. Ooh. What if we take out that half? If we use that half, then we get what? Divide 2 here. This is cosh 2 theta, and then plus 1. Right? Because we're dividing everything by 2. Right. Okay. Would you rather do this? Then, you know what? Yes. I probably would. I'm going to take in that half, of course. Cosh 2 theta, negative 1, 0. And then we get, let's see, if we integrate, we get 1/4 of sinh 2 theta. And then 1/8 of cosh 2 theta. Okay. And then the other is just theta squared over 4. Okay. So then we'll go ahead and plug in our answer. We get theta 4 of sinh 2 theta minus 1/8 of cosh 2 theta. And then plus theta squared over 4. And so now we plug in x, and we get inverse sinh over 4 of sinh of 2 inverse sinh. Our answers have been very long. 1/8 of cosh 2 sinh inverse, and then plus 1/4 of inverse sinh square plus c, and then this whole thing is our answer. Okay? Alrighty, our last integral is this. Awesome. So I immediately see ln. Okay, we know this is a hyperbolic Trig-Sub. So let x equals sinh theta. So now we can convert this, and this is simply theta, sinh theta, cosh theta, right? And then we have cosh theta at the bottom, and then this is simply integration by parts, so we could just go ahead and do that. And then now we see that this is just theta cosh theta minus sinh theta. And so now our answer is just inverse sinh of x, cosh of inverse sinh, and then now it's minus x plus c. So thank you guys so much for watching. That's all hyperbolic substitution tricks. I hope this is very helpful for you. So yeah, I'll see you guys in the next part. Thank you guys.